In our next projectile type example, we're talking about a canyon on a fort, and the canyon is located 10 meters above the ground. If the canyon fires a cannonball at 50 meters per second horizontally, how far will it go? Remember, we have to treat the horizontal and the vertical components separately. Let's look at the horizontal component first. How far will it go? We're really looking for a distance in the x direction. And the velocity in the x direction is 50 meters per second. And because it's fired totally horizontally, all of that velocity is directed in the horizontal direction. However, we do not know the time. And remember, this is the x direction. Let's look at the y direction now. We know the ball is, or cannonball is located 10 meters above ground. So at the end of the day, the cannonball will displace a distance of negative 10 meters because it will drop 10 meters to the ground. We know also it is undergoing acceleration due to gravity, so that's acceleration negative 9.81 meters per second squared. Its initial velocity, v1, we know it's 0 because if the cannonball is fired horizontally, none of that is in the vertical component, so the vertical velocity is 0. Lastly, we need to find time. Because time is constant between the horizontal and the vertical component, it can be found using either the horizontal or the vertical component. And because we have 3 of the 4 necessary kinematics equation, we're going to use the y direction, the vertical direction, in order to find the time. The kinematic equation we need to use here is d equals v1t plus 1/2 at squared. And the first term, v1t, becomes 0 because our initial vertical velocity is 0. And remember, we're looking for t. Isolating for t, we have t equals 2d divided by a. I'll take the square root of that. Equals 2 times negative 10 meters divided by negative 9.81 meters per second squared, square root. Putting that into a calculator, we find that the flight time of the cannonball is 1.427 seconds. Now that we have this value, we can take it and bring it into our horizontal direction and use it to find the range of the ball. So we know d equals vt, d equals 50 meters per second, and the ball was traveling for 1.427 seconds. We put that into a calculator and we get 71.392 meters. Taking into account significant digits, our final answer is it will travel 71 meters. Now, it appears to be a very complicated question, but again, the trick is to keep the horizontal component separate from the vertical component. However, remember that flight time can be determined using either the x component, the horizontal component, or the y component, and then used in both sections. The next iteration of our cannonball example is very similar to our first one. However, it is now fired at an angle, but we're given its range and its total flight time. We're asked to find the velocity that the cannon fired the cannonball. And remember, because it's an angle, we have to find both the horizontal component of the velocity as well as the vertical component of the velocity. So once again, we have to separate the horizontal and the vertical component. Let's look at the horizontal component first. In order to calculate velocity, we need the range, and that's given to us. It's 180 meters. And we're also told a flight time of 2.7 seconds. To find the horizontal velocity, we just need to use the equation Vx equals dx divided by t. Our range, or vertical or horizontal distance, was 180 meters. Flight time of 2.7 seconds. So then we can calculate our horizontal velocity was 66.6 repeating meters per second. In the vertical direction, once again, we need to find v1y. And because it's now in the vertical direction, we know this object is undergoing acceleration due to gravity. So acceleration is negative 9.81 meters per second squared. Our flight time is 2.7 seconds. And we also need to know that the ball at the end of the day will fall at a distance of negative 10 meters. Looking at those kinematic variables, we'll need to use the kinematic equation D equals V1t plus 1/2 AT squared. We're looking for V1, and once we isolate for V1, our equation becomes V1 equals D minus 1/2 AT squared, all divided by T. Remember to manipulate your equation properly. And now we substitute V1 equals negative 10 meters minus 1/2 negative 9.81 times 2.7 seconds squared, all divided by 2.7 seconds. So we find that our velocity is 9.539 meters per second. Now that is our vertical component of our velocity. We need now to put in our horizontal component with our vertical component using Pythagoras to find the velocity. So the velocity is really 66.6 repeating squared plus 9.539 squared square root. And doing all that math, our final answer becomes 67.345 meters per second, or rounded to proper sig digs, 67 meters per second.